See the first slide. Astha Kiran, you can do. This is the current question. Again, I am repeating this question. You can see this question. The car from A takes 8 hours to reach B. So a speed of car from A will be 480 by 8, that is 60 km per hour. And car from B takes 12 hours to reach A. So the speed of car from B will be 480 by 12, that is 40 km per hour. Now they have started at the same time towards each other. Suppose, for example, they have started at 9 a.m. and they have met here at 10:30 a.m. So time taken is 1 hour 30 minutes to meet. So obviously time taken by car A to reach this meeting point will be 1 hour 30 minutes. Time taken by car from B will also be 1 hour 30 minutes to meet at the meeting point. Why? Because time taken will be same, because they have started at the same time. But distance traveled by the two cars to reach the meeting point will be different. Why so? Because their speeds are different. Okay. So time is same. So I have just used d1 by d2. d1 represents the distance traveled by car from A. d2 represents distance traveled by car from B. So d1 by d2 equal to s1 by s2. That is 60 by 40. That is 3 by 2. For d1 I have written dA. For d2 I have written dB. dA means distance traveled by car from A to reach the meeting point. And dB represents the distance traveled by car from B to reach the meeting point. Here we have to find dA. And ratio between the distances traveled is 3:2. So we have to find 3. So 3 divided by 3 plus 2 of total distance 480. 3 plus 2 is 5. So 3 by 5 into 480, and that is 288 kilometer dA. That is distance from A to the meeting point is 288 kilometers. Apurva Singh, it will take some time because Chandan Gupta, they have taken 8 hours or 12 hours to reach their respective destination. Neha Soni, I have explained why time is same. You can see to reach the meeting point, time taken will be same, obviously, but distance traveled will be different. See the question. Maleppu Sri Harse, you joined the class late, I think. This is the answer of first question. This is first question. Harminder Singh, you have to find the distance from A. Distance from A, that is dA. That's why 3 by 5 of total distance between A and B, which is 480. Okay. This is the next question. A plane left half an hour later than the scheduled time, and in order to reach its destination 1500 kilometers away in time, it had to increase its speed by 33.33% over its usual speed. Find its increased speed. In this question, again we have to use ratio. You have to see in the two situations what is same. Accordingly, you use the ratio. Jaya Kumari, if both the car started at suppose 9 a.m. and they have met at suppose 10:30 a.m. means time taken by each car is 1 hour 30 minutes. So time is same. But distances traveled by the two cars will be different. Why so? Because the speeds are different. Try this question. Try this question. Question is, you can understand a plane left half an hour later than the scheduled time. In order to reach its destination 1500 kilometers away in time, it had to increase its speed by 33.33%, that is one third, over its usual speed. Find its increased speed. That you have to find. Again, in this question, you have to use ratio. Just you have to see what is same in both the possibility, in both the cases, or in both the situation. Keshav, not correct. Sarad, not correct. Anjali Kataria, your answer is correct. Please send your answer in Dhruv sir profile. Safna KP, your answer is correct, but please send your query in to Dhruv sir profile. Mehta, not correct. Ashish Gorian, not correct. Mahima Hari Krishnan, your answer is correct. Parul Patel, your answer is correct. Keshav, now your answer is correct. Ashish Gorian, Devashish Dubey, your answer is correct. Naveen Rai, your answer is correct. Abhishek Rajput, in this question, you have to find increased speed. Increased speed, not the original speed. No, Rajneesh. No, Ayush. Rajneesh Kumar, now your answer is correct. Harminder, not correct. Not correct. Anjali Surya, your answer is correct. Divya Sri Patra, your answer is correct. Kajal Kumari, you can see the last line of the last question. Priya, please ask your question. Bhavna, not correct. Santanu Kumar, your answer is correct. No, Avinav Raj. You have to find increase the speed. Isita Gupta, no. Manisha Yadav, no. Okay, stop. Now I am doing this question. Answer is 1,000 km/h. So please check your answer. Answer is 1,000 km/h. I am doing. Please concentrate. I am doing this. A plane left half an hour later than the scheduled time. Its destination 1,500 km away in time. It had to increase its speed by 33.33% over its usual speed. Find the increased speed. See, the distance is 1,500 km. So this is 1,500 km. Okay. Now normal speed is suppose x, and normal time is suppose t hours. Okay. And when time is t minus half hour, because the plane started half an hour later, the speed should be one third more, that is x plus one third of x. Why? 33.33% means one third more. If you solve this, this is 4 by 3x. This is the increased speed. This is the increased speed. Now you can see that the distance traveled in both the situation will be same. That is 1,500 km. So you can use, see, we have to find increased speed, that is we have to find 4 by 3x. Now distance traveled is same in both the situation, means ratio of speed equal to inverse ratio of time, and solve this x and x, and this is 3 by 4 t minus half by t. Solve this, cross multiply, 3t equal to 4t minus 4 into half. This is 3t, 4t minus 2. So t equal to 2. So normal time is 2 hours. Normal time is 2 hours. So this time, that is for increased speed, time will be 2 minus half, that is 3 by 2 hours. So increased speed will be, that is increased speed will be distance traveled by time taken 3 by 2. Solve this, this will be 1,000 km/h. This is the answer. Puja Bharati, because in the question it is written that half an hour later the plane started. That's why for increased speed, time will be t minus half hour. Again I am repeating. See the question. A plane left half an hour later means, obviously half an hour later means from usual time, the time taken will be half an hour less than the scheduled time, and in order to reach its destination 1,500 km away in time, it has to increase its speed by 33.33%, that is one third, over its usual speed. Find its increased speed. Here you can see, suppose normal speed is x km/h and normal time is t hours. Now, since the plane started half an hour later, so now the time taken will be, because the plane has to reach the destination in time. So now time is t minus half hour. T minus half hour, that I have written here. And the speed is what? X plus 1 by 3x. Speed is increased by one third, 33.33%. So 4 by 3x. Now you can see in both the situation, the distance will be same, 1,500 km. So distance is constant. So we can use S1 by S2, this ratio. Ratio of speed equal to inverse ratio of time. And from that, just a minute. Just a minute, there is a problem in the screen sharing. Okay. Okay. So from that you can find the time. Normal time is t equal to 2 hours. Normal time is t equal to 2 hours. So for the increased speed, time is t minus half hour. That is 3 by 2 hour. 2 minus half, that is 3 by 2 hour. So what is the speed? Increased speed is 1500 kilometer divided by the time taken 3 by 2. That is 1000 kilometer per hour. That is the increased speed. I hope you understand now. Now try the next question. Next question is general question. Here you have to use distance equal to speed into time. Very easy question. In this question you have to use distance equal to speed into time. Chahat Smriti is in reverse because distance is constant. Distance is same. Then you have to use inverse ratio that I have explained in the last class. Please see the video of last class. Chandan Gupta, I have repeated so many times. Okay, you can see the last question. See the solution. Wait, Vapya, wait. For the current question, Parul Patel, your answer is correct. Kesav, your answer is correct. Jagan Mohan Reddy, come to your original name, otherwise I will not take your name from next time. Divyasri, correct. See the current question. Neha Soni, not correct. Anjali Kataria, this is the question, current question. Just a minute, I am showing the screen. Current question, Chanda. Ashish Gorian, your answer is correct. Safina KP, your answer is correct. Isita Gupta, correct. Parna Borhade, your answer is correct. Nityanand Oja, your answer is correct. But write your answer in Dhruv Sir profile. Karan Sinha, your answer is not correct. This is very simple question. Here only you have to use distance equal to speed into time. Vapya, your answer is correct. Oh, sorry, no, not correct. Nidhi Kumari, your answer is correct. Nisa Go, Ajay, your answer is correct. Nitish, your answer is correct. Deepak Nair, Mitendra Kumar, Sagar Parma, Prasun, answer is correct. No Harshvardhan Singh Rathore. Bhavana, your answer is correct. Shweta Kumara, your answer is correct. Anjali Kataria, correct answer. Anupriya Swaraj, Nandini Raj, correct answer. Nisul Urao, your answer is correct. Kumar Ayush, Jaya Kumari, your answer is not correct. Anvesha Das, your answer is correct. Parag Bhosle, your answer is correct. Kiran Bharti, Akshit Rohila, your answer is correct. Stop now, stop now. Please write your query in the chat of Dhruv sir. Shubham Kumar, not correct, but write your query in the chat of Dhruv sir. Okay, Harvinder, not correct. Avilasa, correct. Stop now. I am doing the question. Answer is 24 kilometer. Answer is 24 kilometers. See how. Question is, Jayasri goes to office at a speed of 6 kilometers per hour and returns to her home at a speed of 4 kilometers per hour. If she takes 10 hours in all, what is the distance between her office and her home? This is the question. This is home and office. Now, goes to office at a speed of 6 kilometers per hour and returns to her home with a speed of 4 kilometers per hour. And for to and fro journey, she takes what time? 10 hours. 10 hours. Okay. Now, suppose the distance between her home and office is d kilometer. No issue, Palak Chaurasia. Okay, d kilometer. So for to and fro journey, time taken is 10 hours. So for going to office, time taken will be d by 6, and from returning, the time taken will be d by 4, equal to 10 hours. Just solve this. LCM of 6 and 4 is 12. So 12 by 6 to 2d, and 12 by 4 3 into d, that is 3d, equal to 10, means 5d equal to 120. So d equal to 120 by 5, that is 24 kilometers. So distance between her home and office is 24 kilometers. Very simple question. I have just used time equal to distance by speed. Surya Prakash, no issue. Try to go through the recording again and again and try to understand the logic, how questions are solved, how you have to think. No, Abhishek. See, from home to office, d is the distance. Obviously, from office to home, d is the distance. And for going to office, the time taken will be d by 6, distance by speed. And for returning from office, time taken will be d by 4. And the total time is d by 6 plus d by 4 is 10 hours. That is given in the question. And just solve for d, and that is 24 kilometers. That is 24 kilometers. Please write. Okay, now next I am talking about next subtopic. Next subtopic I am discussing, and that is relative speed. that is relative speed. Many questions you can see from relative speed, and I have discussed relative speed in, I think, clock chapter also. So relative speed, just see what is this. Avinam Sarma, why you are so slow? See the last question, this one. Go Subham, please check. Shreya, you can talk to your academic coordinator. Abhishek, might be I have missed the answer. Use Raju, 10 hours total time taken for to and fro journey. For to and fro journey. Okay, now I am talking about relative speed. Relative speed, see, there are two situations. Two moving body can move in same direction or they can move in opposite direction. Two moving body, two trains, for example, two trains can move in same direction or two trains can move in opposite direction. Suppose S1 and S2 are the speed of two moving body. If they are moving in opposite direction, opposite direction means one is going with a speed 1 and other is moving in opposite direction with speed 2, then relative speed will be if sum of the speed, that is S1 plus S2, that is relative speed of one body, moving body, with respect to the second body, You can't poor. Sir, your voice is not audible. Please check your net connection. I'm audible. So, relative speed are two situations. There are two moving bodies, two trains, for example, or two cars, for example, and they are moving in the opposite direction. The relative speed will be sum of the speed. And S1 plus S2 is the relative speed of one moving body with respect to the other moving body. Now, suppose they are moving in same direction. Same direction. So, one body is moving with the speed of S1 and other body is also moving with the speed S2. Then relative speed will be difference of the speed. That is either S1 minus S2 or S2 minus S1. Whichever is positive, you have to take that. If S1 minus S2 is positive, you take relative speed at S1 minus S2. If S1 minus S2 is negative, then take S2 minus S1, that will be positive. So you have to take the difference, and out of S1 minus S2 or S2 minus S1, whichever is positive, you have to take that. So relative speed is difference of the speed, obviously relative speed of one body with respect to the other body, that is difference of the speed. So these two concepts will be used while doing the question. One example I am taking, example is this. Please write. Two trains started at same time. At different time from Delhi. This is Delhi. This is Mumbai. One train started at 6 a.m. from Delhi towards Mumbai with a speed of suppose 60 km per hour. And second train started from Delhi at 8 8:30 a.m. with a speed of 80 kilometers per hour. And repeat again. Two trains started from Delhi towards Mumbai at different time and with different speed. First train started at 6 a.m. from Delhi towards Mumbai with a speed of 60 km per hour. Second train started from Delhi towards Mumbai at 8:30 a.m. with a speed of 80 km per hour. Now there are two questions here. The first question is when the second train will catch the first train. First train. Just a minute. Catch the first train. And second question is at what distance from Delhi the two trains will meet. Okay, these are the two questions associated with this. I am doing this question, I have not given you to solve. Vibhuti, just see the concept. Oh, you are so slow. I am doing the example, don't try. Don't try the example I am doing. Okay, so this is the example. Two questions: when the second train will catch the first train, and or when the second train will overtake the first train, and what distance from Delhi the two trains will meet. That is there. See, this question is general. Based on same concept, many questions can be asked. So try to understand. See, the first train started at 6 a.m. Please write your query in group, sir. Akshit Rohila, I have to teach all of the students. Okay. So please bear with your friends also. Now, the first train started at 6 a.m. towards Mumbai with a speed of 60 km per hour. Second train started at 8:30 a.m. 8:30 a.m. Avnish Kumar Singh, check your net connection. Screen is visible. Second train started at 8:30 a.m. Second train started at 8:30 a.m. with a speed of 80 km per hour. Means the first train traveled for 2.5 hours. Then second train started. So in 2.5 hours, the first train will move how much? 6 into 2.5, that is 150 kilometers. So the first train moved for 150 kilometers, then second train started. So there is a gap of 150 kilometers. This is first train. There is a gap of 150 kilometers when the second train started. When second train will catch first train? When this gap of 150 kilometers will be covered. And the second train will cover this 150 kilometers with relative speed. And since both the train are moving, Aruk Mary 6 a.m. and 8:30 a.m. difference is 2.5 hours. Okay. So second train started at 8:30 a.m. with a speed of 80 km per hour. both the trains are moving in same direction, so relative speed will be what? Difference of the speed 80 minus 60, that is 20 km per hour. It means the second train travels 20 km more than the first train in 1 hour. Obviously, the gap of 150 km will be covered with this relative speed 20 km per hour, and the time taken, I am writing here, the time taken will be 150 by 20. If you solve, this will be 7.5 hours. So in 7.5 hours, means in 7.5 hours, half an hour, the second train will overtake first train. If you add 7.5 hour to 8:30 am, if you add 7.5 hour to 8:30 am, the time will be 4 pm. The time will be 4 pm. So at 4 pm, second train will overtake first train. Now, second question is, at what distance from Delhi the second train will overtake first train? Obviously, in 7.5 hour, how much distance second train will travel? So distance will be 80 speed into time 7.5. If you solve, this will be 600 kilometer. Means after 600 kilometer, the second train will overtake first train. The second train will overtake first train. Okay, and so that is the answer. 4 p.m. answer for the first question. 600 kilometer is the answer for the second question. Dishu Sharma first train started at 6 a.m. and second train started at 8:30 a.m. So there is a gap of 2.5 an hour, 2.5 hours. So in that much time, how much distance first train has traveled? Obviously, that will be a speed into time. 60 into 2.5, that is 150 kilometer. Means when second train started, first train is 150 kilometer ahead of second train. Okay, wait, again I am repeating. See, one thing you have to be clear about, the two trains started at different timing. First train started at 6 a.m. and second train started at 8:30 a.m. So there is a gap of 2.5 hour you can say. So first train traveled for 2.5 hours, then second train started. So in 2.5 hours, the first train will cover 60 into 2.5, 150 kilometer. Means first train is 150 kilometer ahead of second train when second train started. How second train will overtake first train? When this gap of 150 kilometer is covered. And how this can be covered? This will be covered with relative speed, because second train is moving with more speed. So what is the relative speed? Because both the trains are moving in same direction, so relative speed is, you can see, 80 minus 60, that is difference of the speed, which is 20 km per hour. So this gap of 150 km will be covered by second train with relative speed, that is 20 km per hour, and the time is 150 by 20, that is 7.5 hours. And in 7.5 hours, the second train will cover how much distance? 7.5 into 80, and that is 600 kilometers. So if you add 7.5 hours to 8:30 a.m., the time will be 4 p.m. So second train will overtake the first train at 4 p.m. and the distance traveled is 600 kilometers. Means 600 kilometers from Delhi, the second train will overtake the first train. That is the answer. That is the answer. One more thing, what is the significance of this relative speed 20 km per hour? Significance is that every hour the second train is moving 20 km more than the first train. write. Please write. Please write. Yes, Divyanshu Gupta. Yes. Poonam, 7.5 hour. If you add to 8:30 a.m. 8:30 a.m. plus 7.5 hours, that will give you 4 p.m. 8:30 plus 7.5, that will be 16 hours. 16 hours means 4 p.m. Okay. See, on this questions concept, there will be thousands of questions. So try to understand the logic behind this answer, this solution. Okay, now try this question. Santanu, I have asked this question similar to the first question. Question is, two train for Mumbai leave Delhi at 6 a.m. and 6:45 a.m. and travel at 100 km per hour and 136 km per hour respectively. How many kilometers from Delhi will the two trains be together? Obviously, you have to find the distance. Sania, I have repeated so many times. Sania, again, I will repeat the same concept in this question also. Please wait. Aditya Tiwari, in the last question, the second train traveled for 7.5 hours. That's why 7 point into 80 I did. Piyush Raju, that we cannot find. That we cannot find in the previous question. That we cannot find. You can say that data is not sufficient. Rahul, your answer is correct. Nityanand Ojha, your answer is correct. Shreyans Saurabh, you have to find distance. Ashish Gorian, your answer is not correct. Sagar Parma, not correct. Palak Chaurasia, your answer is correct. Pranav Oh, Hade, your answer is approximately correct. If you have given approximate answer, then that's correct. Naveen Rai, correct answer. Murari Kumar, correct answer. Prasun, correct answer. Avilasa, Divyans Puri, correct answer. Abhishek Rajput, correct answer. Ayush Maurya, correct answer. Deepak Kushwaha. Ashish Gorian, now your answer is correct. Anjali Kataria, Shubham Kumar, correct answer. Okay, stop now. I am doing this question. Stop now. I am doing this question now. Please try to understand. Sania, please concentrate. Okay, answer is 283.33 kilometer. Answer is 283.33 kilometer. GQG Rai, Gopal, please write your query in Dhruv sir chat. So answer is 283.33 kilometer. Just see. Question is, two train for Mumbai leave Delhi at 6 a.m. and 6:45 a.m. and travel at 100 km per hour and 136 km per hour respectively. How many kilometers from Delhi will the two trains be together? Okay, same question as the previous one. See, one train is started at 6 a.m. Just a minute, there is a problem with the skill sharing. So, one train is started at 6 a.m. Gopal, your answer is not correct, and write your answer in group search chat. Okay. So 6 a.m. the train is started with a speed of 100 km per hour. Second train is started at 6:45 a.m. and with a speed of 136 km per hour. Okay. Now, first train traveled for 45 minutes, then second train started. So in 45 minutes, first train will cover what distance? 45 minutes means 45 by 60 hour, that is 3 by 4 hour. So the first train will cover 100 into 3 by 4, that is 75 kilometers. Means first train has covered 75 kilometers, then second train started. Obviously, this gap of 75 kilometers, which first train has already traveled, already covered, when this gap of 75 kilometers will be covered by second train, obviously second train will overtake first train. Now, how this gap of 75 kilometers will be covered? Obviously, with relative speed, they are moving in same direction. So, relative speed is 136 minus 100. Difference of the speed, that is 36 kilometers per hour. So, to cover 75 kilometers with relative speed, time taken will be 75 by 36 hours. So in this much time, 75 by 36 hours, the second train will overtake first train. And in this much time, how much distance second train will cover? Obviously, distance covered will be speed into time, 75 by 36 kilometers. And if you solve, this is 283.33 kilometers. And that is the answer. So at what distance second train will overtake first train? Obviously after 283.33 kilometers. See this? See the answer. Harminder Singh, this is the question. Just a minute. Wait, I'm showing the question. There is some issue with the screen sharing. No, Himanshu. Please wait. Please wait. There is problem with the screen sharing. Okay. See, Harminder, question you can see. Be fast. Okay. This is the answer. Okay, okay. Now try the next question. Now try the next question. The question is, a car driver driving in a fog passes a pedestrian uh, who was walking at the rate of 2 km per hour in the same direction. The pedestrian could see the car for 6 minutes and it was visible to him up to a distance of 0.6 kilometer. What was the speed of the car? What was the speed of the car? This is the question. A car driver driving in a fog passes a pedestrian who was walking at the rate of 2 km per hour in the same direction. The pedestrian could see the car for 6 minutes and it was visible to him up to a distance of 0.6 kilometer. What was the speed of the car? Try this. Again, here you can use the concept of relative speed. Kesab, your answer is correct. Parul Patel, your answer is correct. Yajn Balkya, your answer is correct. Nityanand Ojha, correct answer. Gagandeep, correct answer. Debashish Dubey, correct answer. Abhishek Rajput, Ashish Gorian, Anjali Kataria, correct answer. Lorina Sihag, your answer is correct. The speed is there, so this is kilometer per hour. Lorina Sihag, kilometer per hour. Your answer is correct. Anushka, correct answer. Arakya Mary, every year questions are there. 1, 2 question, 2, 3 question. Satakshi Singh, your answer is correct. Rajneesh Palak Chaurasia, correct answer. Nitendra Kumar, your answer is not correct. Please write your query in Dhruv sir profile. Sakshi R. Gorke, your answer is correct. Kancha Gharana, your answer is correct. Murari Kumar, correct. Kausal Sharma, your answer is not correct. Okay, stop writing. Answer is 8 kilometer per hour. 8 kilometer per hour. Answer is 8 kilometer per hour. You can see. A car driver driving in a fog passes a pedestrian who was walking at the rate of 2 km per hour. Suppose pedestrian is this and pedestrian is walking with a speed of 2 km per hour. Car driver driving in fog and passes this pedestrian. The pedestrian could see the car for 6 minutes and it was visible to him up to a distance of 0.6 km. So car is here now. Car is here now. Car is here now. Now pedestrian could see the car for 0.6 kilometer, or it is also given that for 6 minutes. And this car has moved ahead by 0.6 kilometer, obviously with relative speed because pedestrian is also moving. Suppose the speed of car is x kilometer per hour. So car has gained 0.6 kilometer over pedestrian with relative speed. Both are moving in same direction, so relative speed is difference of x and 2 x minus 2. Now with relative speed the car has covered 0.6 kilometer in 6 minutes. So speed, relative speed into time 6 by 60 hour, because we have to convert minute into hour here, equal to distance that is 0.6 kilometer. That we have to solve. This is x minus 2 into 1 by 10. 0.6 you can add 6 by 10. 10 and 10 cancel. So x minus 2 equal to 6 implies x equal to 8 kilometer per hour. So that is the speed of car, actual speed of car. You can see from here. Pooja Bharti, the pedestrian is moving with the speed of 2 km per hour and car comes from behind and moves ahead. So obviously car has gained 0.6 kilometer with relative speed because pedestrian is also moving, and car has gained 0.6 kilometer in 6 minutes. Suppose the speed of car is x kilometer per hour. So relative speed will be difference of the speed because both are moving in same direction. That is x minus 2. So here I have written x minus 2 into 6 minutes, that is in hour 6 by 60, equal to distance 0.6 kilometer. Solve this. 6 by 60 means 1 by 10, 0.6 means 6 by 10. 10 and 10 will cancel each other. So x minus 2 equal to 6, that is x equal to 8 kilometer per hour. So you can see from beginning, this is the question. Mithendra, 6 minute, that is minute, not speed. Relative speed is difference of a speed. Okay, next right. Next right. Next right. Average speed. Next right. Average speed. Next subtopic, average speed. Deepak Anand, I have repeated 2-3 times. Next right, average speed. Next right, average speed. Deepak Anand, you can see in the last question, the pedestrian is moving with a speed of 2 km per hour and car is moving with x km per hour. Car crosses the pedestrian and moves ahead. Car gained 0.6 kilometer. Obviously, car will gain with relative speed because pedestrian is also moving. So, car has moved 0.6 kilometer with relative speed in 6 minutes. So, I have taken relative speed as x minus 2. So, x minus 2 into time, that is 6 by 60. In hour, I have converted, equal to distance, that is 0.6 kilometer. And rest is calculation. X equal to, yes, pedestrian is person. Person is moving. Okay. So I am discussing average speed. Uh, Average speed. Always remember a speed equal to, or average speed equal to distance traveled by time taken. Always remember. Distance traveled by time taken. First type of question will be related to and fro journey. To and fro journey. Suppose someone goes from Delhi to Simla with a speed of 50 kilometer per hour and returns back with a speed of 40 kilometer per hour. Now the question is, what is the average speed during the entire journey? Here time is not given. I repeat, someone goes from Delhi to Simla with 50 km per hour and returns with a speed of 40 km per hour. What is the average speed? See, for to and fro journey, there is a formula. Formula also, and formula is average speed equal to 2xy by x plus y, where x and y are the two speeds, where x and y are two speeds. So you can use, and this is 2, x is 50, y is 40 by 50 plus 40. If you will solve this, 0, 0 cancel from here. This is what? 400 by 9 kilometer per hour. That is the average speed. 400 by 9 kilometer per hour. That is the average speed. Again, I am repeating. Average speed, always remember distance traveled by time taken. First type of question I have taken here, to and fro journey. From Delhi to Simla, someone goes with a speed of 50 km per hour and returns with a speed of 40 km per hour. Average is for this type of to and fro journey, there is a formula, that is 2x by x plus y, and where x and y are a speed. So put 50 in place of x and 40 in place of y. And if you calculate, this is 400 by 9 km per hour. Abhishek Rajput, you can cancel 1 0 from numerator and denominator both. So 400 by 9 km per hour. Now someone said me, why 2x by x plus y? You take the distance, you can see like this. If the no Ayush Maurya, not always. For this situation only I have taken 2x by x plus y. Suppose distance is d. So I have told you that average speed is distance traveled by time taken. So d and d for to and fro journey, 2d distance, at time will be d by 50 plus d by 40. That will be total time taken. If you solve, d and d will cancel and this will come out to be 2 into 50 into 40 by 50 plus 40. And that I have calculated here. You can see yx plus y, mathly you can see 50 plus 40. If 50 is x, 40 is y, then you can see this is x, this is y, this is x, this is y. Yes, Chiku, 0. You have to cancel only 1 0. I have calculated 1 0 from numerator as well as denominator. Akash Kumar Baral, because for to and fro journey, d plus d, 2d. I have calculated this just to show you why I am taking 2 into x into y by x plus y. Why I am taking 2xy by x plus y. Now, no, same formula, Akanksha Kumari, I have shown here why 2xy by x plus y. So I have taken the distance between Delhi and Simla as d, and I have solved here 2d, that is the total distance traveled, d plus d, and time taken will be d by 50 plus d by 40. So I have written here distance traveled by time taken, and this is same as 2xy by x plus y. X is 50, y is 40. Just to explain the logic behind this formula, I have written here. Time taken, d by 50 plus d by 40. D by 50 plus d by 40. Now, suppose there is a change in the question. That is, while returning back, the person cover half of the distance with 40 km per hour and half of the distance with 60 km per hour. Then this formula will fail. I repeat, while returning back, the person cover half of the distance with 40 km per hour and remaining half with the speed of covers with the speed of 60 km per hour. Then this formula will fail. So there is a general approach. No, Gaganti, general approach. General approach, you can see. General approach is you take some distance between Delhi and Simla, and best is you take the LCM of 50 and 40. So you take LCM of 50 and 40, that is 200 kilometers. You take the distance between Delhi and Simla as 200 kilometers. So the person moves with 80 km per hour and returns back with 40 km per hour. Now the average speed will be distance traveled that is 200 plus 200. Time taken will be 200 by 50 for going to Simla, and for returning from Simla, time taken will be 200 by 40. Solve this. This is 4, this is 5, so this is 400 by 9 kilometer per hour. This is a general approach you can apply anywhere. So why I have taken 200 kilometer and how I have taken 200 kilometer as distance in Delhi and Simla, that is the LCM of a speed 50 and 40. That is the LCM of the speed given 50 and 40. Now I have taken, which is 200, so I have taken distance between Delhi and Simla as 200 kilometers. So going to Simla with the speed of 50 kilometers per hour and returning from Simla with the speed of 40 kilometers per hour. So average speed will be distances traveled by time taken. That is 200 plus 200. Time taken will be 200 by 50 for going to Simla, and for returning time taken will be 200 by 40. So 400 by 9 kilometers per hour. Within this is the approach. This is the approach. And this approach can be applied for any type of question. This approach can be applied for any type of question. Yaksan Hussain, only the first situation which I have discussed in the beginning, there you can use the formula. For any other situation, you cannot use the same formula. You should apply this approach. Yes, Rajni's LCM of a speed I have taken as distance. Why LCM of distance I have taken as LCM of a speed I have taken as distance? Because it will Mitendra, yes, distance can be found by using LCM, because calculation will be easy. Calculation will be simplified while taking LCM of a speed. Okay, that's all of today's class. I will Mathly. Yes, Mathly can be used in any situation, the general approach. Jyoti Sarup, I have just used distance traveled by time taken. General approach is you take the distance as LCM of a speed, total distance traveled by time taken. Yes, Divyans, you can use anywhere. So that's all of today's class. I will continue this tomorrow. General approach can be applied for any question. So that's all of today's class. Thank you. I will continue this tomorrow. Tanvi Chavan, you can contact your academic coordinator. I have shared all the PDF. Yes, Shubham. Yes. You can see the first slide. For today's class. This is the first question. Khan Sivangi, why we multiply with 2? General approach. Use Raju, many classes are left. This is not a school education. Okay, Shubham, I will try. This is the first slide. Okay, thank you for today's class. Thank you.